Supply chains are complex, and securing your software supply chain is no exception. From the huge number of components and dependencies that you use from a wide variety of sources, to your developers adding their own code, to your applications being delivered to users around the world. How do you keep track of all this? At AIMCore, we believe that managing and protecting your software supply chain starts with establishing trust. And that trust begins with understanding and managing your software bill of materials, or SBOM. SBOMs function as an ingredients label for software. And when you track and manage the ingredients, you can trust the components you use or bring into your development pipeline. It starts with verifying the provenance of open source code and validating supplier SBOMs, and keeping a repository of SBOMs to track the ingredients of your software over time. And maintaining trust as you build, with continuous automated security that uncovers vulnerabilities, malware, and leaked secrets, with compliance checks to root out any critical issues. Then, when you're ready to deliver your software, providing SBOMs and continuing to monitor for security risks after deployment, so your users can trust you and rest assured that the software you deliver was built securely every step of the way. To learn more about AIMCore's software supply chain management solution, visit us at aimcore.com.
Good afternoon. Welcome everyone to today's webinar brought to you by AIMCore. Today's topic is adopting the DoD software factory model. For those of you that are new here, a few housekeeping things. Pretty much there's a chat box to the right. It's nice to see so many people from all over the world joining us today. Welcome everybody. And then after today's session, you will get emails, recording, and the slides as well. Now, our hosts today are two of my esteemed colleagues. We have Brian Thomason, Partner and Solutions Engineering Manager, and Michael Simmons, Senior Solutions Architect. With that, I'll invite Brian to come on stage and hand it over to you.
Good afternoon, good morning, good evening, depending on where you are. I don't know about esteemed, but I do head up the Partner and Solutions Engineering team here, and I notice everybody's announcing where they're from in the chat. As you can tell from my voice, I was born and raised in New York City, so that's where I'm from, just to get to know me a little bit there. Let's move on, and let's start diving right in today to what we want to talk about, which is you're securing your software pipelines, how the government's going about doing it today, where they're moving, and really what the enterprise is emulating as well. So Michael's having trouble with audio. Amber is as well. Maybe if you could look into that on the sidebar there while we move on, because it looks like most people are hearing loud and clear.
Yeah, I can hear you just fine, but I'll do some checking with those folks. Good
deal. So a couple of years ago, the Department of Navy specifically released what they call RAISE. The government, as you know, loves their acronyms. This one is Rapid Assess and Incorporate Software Engineering. They're trying to create a methodology by which software supply chains, DevOps platforms can standardize, if you will, on a set of security principles so that not each and every team within the government, software development team within the government, has to seek their own authority to operate. And we'll elaborate on what that means a little bit later for those that aren't aware. And so they've come up with this RAISE documentation, this RAISE implementation guide, which speaks specifically to the future. It speaks specifically to containerized applications. So this is an aspirational goal of the government to move towards what are called RAISE platforms of choice moving forward, so that any software development team can simply build their software on this platform and inherit the security controls inherent to that platform rather than having to seek an ATO themselves. So basically what that means is an existing DevSecOps platform, and we'll refer to two later on today specifically within the government, but any of those that wishes to allow to seek this designation must adhere to the implementation guide standards, and you can kind of see that laid out below. Now, to our knowledge today, no one's actually even achieve this goal. This is just aspirational. And they're laying out the set of guidelines by which you must adhere to eventually achieve this goal. And in doing so, they're not only standardizing around practices, but also pieces of software. And that's where Anchor comes into play. So the requirements include continuous monitoring, ongoing vulnerability scans, ad hoc vulnerability reporting, and a dashboard providing that reporting, penetration testing, and ad hoc auditing via cybersecurity dashboard. Now, obviously, no tool out there does all of these things, and you can see in bold where Anchor Enterprise comes in. And that's what we're going to talk a little bit about today. And then we're going to hand it off to Michael at the end to actually show you how we integrate within a DevSecOps pipeline, and specifically which ones the government are using that use Anchor today. So without further ado, for those that aren't aware, let's tell you a little bit about Anchor Enterprise. So we provide what we call 3 pillars of functionality within Anchor Enterprise. As the video kind of alluded to, SBOM management is where it all begins. So we have open source tool called SIFT, which generates a software bill of materials, otherwise known as an SBOM. It captures all of the software within your build. We're specifically focused around containers, but you can also build SBOMs out of your source code within your GitLab environment as well, and actually tie those to your containers so that you can track from end to end, and we'll touch on that a bit in a minute as well. So everything begins with an SBOM in Anchor, and that we're kind of unique in that regard. Most other vendors kind of begin with a vulnerability scan, and then you can output an SBOM if you wish to. We actually create the SBOM first to get a complete bill of materials, upload that into Anchor Enterprise, and then do the other 2 pillars of functionality atop that SBOM. So vulnerability management is probably what we're most known for. We basically take that SBOM, scan your container, make sure there aren't any vulnerabilities present. If there are, we expose those to you and allow you to then feed those to our compliance management system, or a policy engine, we call it, and then compare that against certain policy packs that allow you to comply with federal standards or within standards that you identify within your own organization. So policy packs are completely customizable. You can write one from scratch, or you can use the ones out of the box that we provide for certain governmental standards, and we're going to go into those in the next slide. But the first question would be, why Anchor, right? Why has the federal government chosen Anchor in so many situations? And why should you, if you're building a software pipeline, choose Anchor? The first and foremost, again, we're SBOM centric. It's very important to the government knowing what ingredients are in the software they're spitting out to the general public. We provide the most high fidelity SBOMs on the market. For those that are familiar with SBOMs, you've probably heard of SPDX and Cyclone DX. Those are kind of the 2 reigning standards, but they're somewhat old at this point. They don't capture as much information as modern software really needs to have captured, especially in regards to open source software and transient dependencies. And so that's where SIFT came in. We started the SIFT project that I mentioned before. It's an open source tool that creates the SBOMs that feed into Anchor Enterprise. And they have more information than the other 2 standards provide. So we provide high quality SBOMs. Given that high fidelity SBOM, we can also curate our feeds within Anchor Enterprise based on that detailed information to produce lower false positives when it comes to vulnerabilities. So we have a feed, and what we call an exclusion feed within Anchor Enterprise, which has around 13,000 entries today and is constantly growing. It's constantly being curated by our security team that prevents false positives from rearing their ugly head within your operations. And then the other 3 things I'd like to highlight here: federal standards. We're going to touch on these in just a second. The out-of-box compliance with CIS, NIST, and other standards within the government. We are IL5 ready, so your entire solution can be employed as an air-gapped environment. Enterprise is obviously kind of like SaaS offerings these days, but we found within the government, they much rather host that on-prem and actually air-gap that environment so it's not phoning home in any way, shape, or form. We're one of the few products on the market that allows for that. And then last but not least, our flexible API. You're going to get a demo a little bit later. It's going to include our UI, but just know that anything that Michael shows in the UI can be done via API. 100% API-driven platform. Out-of-the-box integrations for many different things. But for those that don't exist, we have a REST API and you can implement yourself. So just to kind of reiterate those benefits on the right side here, what these 5 things allow for is easy integration within your software pipeline, speed to compliance using our policy engine, and 0 data readiness so that you know exactly what's in your software so that the next time a 0 day like Log4j occurs, you'll be ready to address it and fix it. So that is why governments, in a nutshell, choose Ancor for their software pipelines. So how do you integrate it into your pipeline? As I mentioned before, 100% API driven. We have out-of-the-box integration with many of the things that you see on your screen. And if you don't see it on your screen, again, we provide a REST API and a GraphQL API for that matter, which allows for easy integration with any tool of your choice. But as you can see, we have a plethora that we integrate with today out of the box. Primarily in the government space, we see GitLab. We drop in quite nicely there. We also integrate with Harbor, which is another image registry that's heavily used by the government. But again, if you don't see it on the screen, 100% API driven, you still integrate it yourself. And we recommend that you do that at all stages, because a lot of people only scan their software at build time or perhaps at the other end at runtime, but dependencies can creep in at any stage. Your developer can accidentally pull in code into the image before it goes live. When it's being built, certain automated processes can accidentally pull in dependencies that you didn't scan for. And even registry bombing can take place, and it can happen at that stage as well. So we recommend that you scan your image, your container image, with Ancor at every stage of your DevOps process for that reason. And when you scan it, our policy engine kicks in and allows you to automatically comply with certain standards that the federal government lays out. As you can see here from left to the right, these are our three most popular out-of-the-box policy packs that we have. We have the DoD policy pack, which contains checks for NIST 800 series. And we have the SIS policy pack, which mainly checks for like Docker benchmarks and things of that nature, making sure that your containers are not violating any hardened principle standards there. And then last but certainly not least, the one that Michael's going to show off a bit today is the CISA policy, which checks for known exploitable vulnerabilities. So many vulnerabilities are theoretical, right? No one's actually exploited them yet. They're ranked, low, medium, high in terms of impact, but it doesn't necessarily mean anyone's actually even in the wild exploited that vulnerability yet. Whereas the KEV list actually shows a list that has been exploited. So you definitely want to treat those first, especially those on the high list, right? And so Michael's going to show off today how out of the box and this is actually a new feature with an Ancor, you can actually filter based on KEV entries, not just high, medium, or low. Last but certainly not least, in terms of features, zero-day challenges, right? So one of the things we keep hearing about over and over, even to this day, is the Log4j vulnerability that occurred years ago now. People still have it in their software because they don't know where it lives. So we found that monitoring, like I said, end-to-end, integrating at every step of your cycle, creating an SBOM at every stage of your cycle within your software pipeline allows you to track every bit of software and exactly where it lives within your ecosystem. And so when we polled some of our customers, we got some amazing findings, right? 86% of them said it was difficult and time-consuming manually to try to identify all of the software using Log4j. This is industry-wide. But for Ancor users, as you can see on the right, they were easily able to do it. As you can see from a couple of our customers here, without Ancor, I would have had to send out an alert about Log4j to the development teams. In other words, had to manually do it, have them do it individually. Would have largely fallen on deaf ears because they have other projects that they need to attend to. And it would have taken months, if not years, for them to remedy it. But with Ancor, they were able to immediately generate a report of identify the impacted applications and teams, send that out, and mandate its fixing. One of our customers actually did so within 48 hours. They actually identified where Log4j lived across their entire ecosystem and actually upgraded to the newer fixed version within 48 hours across their entire state. So one of the major features that Ancor provides is tracking all of your dependencies and where they live. God forbid we ever do have another Log4j, but it's probably only a matter of time. And then I want to touch briefly on who's using us today, right? So I gave you the why of the federal government. I gave you how Ancor ties into your software pipeline. Here's the who. So we are very entrenched, we are happy to say, in the DoD space. One of our flagship customers is the Navy, specifically Sigma Defense, working on behalf of the Navy. They have created a pipeline system known as Black Pearl. It provides a secure DevOps platform that unifies and streamlines development across the DoD enterprise. And they are trying to accelerate the deployment of software applications while simplifying complexity and lowering costs. So within the Navy now, there's a lot of silos, right? Everyone's building their own software their way, within their own pipeline, within their own platform. There aren't any standards, there aren't any central locations by which for them to build, deploy, and scan for vulnerabilities. So that's where Black Pearl has come into play. And here's a little bit of a look at a high level of how it works, right? So they use GitLab, like most of the government, for their revision control system for their software. They send that to a build process, which builds a container image. That container image, as you can see with the up arrow here, is then sent to Anchor to be scanned for vulnerabilities, as well as policy compliance like we talked about before. And then that data is automatically exported to the EMAS system. And for those not familiar with that, it's basically an online government system that allows you to do vulnerability checks, STIG management. They're trying to make that kind of the end-all be-all for security interface, if you will, for the federal government, or for the DoD. And so another one of our major customers, and probably our first flagship customer within the DoD in general, would be Platform One. So this is the Air Force. They've built an entire end-to-end solution, and I'm going to let Michael talk a little bit more about this because he actually was an engineer that helped build Platform One, worked there for around 4 years, if I recall correctly. And I'm going to allow you to take it over now, Michael, and tell us a little bit more about Platform One and Iron Bank and how they use Anchor today.
Awesome. Thank you, Brian. Yeah, so like Brian mentioned, Platform One, as more specifically, their Iron Bank is one of the largest DoD software factories. And they're providing hardening pipelines to harden both open source and then vendor-supplied commercial off-the-shelf software to meet the DoD's container hardening guide requirements that were put out in 2022. So what they're doing, and I'll go on to the next slide here, is they're requiring vendors to submit their software and artifacts, and then from there, and they also are using GitLab for this this whole process for their version control. Those vendors are going to submit their software and their artifacts, and those are going to be things like a Docker file and a hardening manifest, which is going to lay out all of the dependencies that will be pulled in during the build process. They're going to go ahead and build that image, and then they will send it to Anchor again for vulnerability and policy enforcement on that image. Once that application is built, the results are made available as part of a body of evidence, and it's imported into their VAT tool, or the vulnerability assessment tracker, which is going to allow the vendor or whoever is hardening that that particular image to go in and submit justifications for any findings that might still be in there. From there, those justifications are going to be reviewed by a security team, and then they'll run through an engine that's going to do some scoring based on time that vulnerabilities are in there, and a number of factors, including criticality of those findings. And then they're made available from there. They're promoted to the Iron Bank registry, which is Registry 1, and then made publicly available. Then all these applications and all these images are rebuilt on a regular basis to ensure that all the vulnerability and policy information is up to date. All right, so now that we've taken a look at these software factories, we're going to kind of dive into how do we kind of go through this process, and how do we build a software factory, if you will. So I'll go ahead and share here. All right. So first off, we'll say, how does Anchor help with this whole process? And this is going to kind of come in 3 key pieces for a software factory. That's going to be an SBOM, or a software bill of materials. It's going to be vulnerability information, and then policy results. So first off, when we scan an image with Anchor, we're going to generate that SBOM. That is how Anchor catalogs every image that's been scanned. And the beauty of that is we can take that SBOM, store it for a long period of time, and then apply new vulnerability data and policy compliance information on top of that to get a result even a long period of time after we've generated that initial SBOM. And as long as that digest for that particular image hasn't changed, we know that the SBOM itself hasn't changed, and we can keep getting new results for that. So here what we're looking at is just an image that we scanned with Anchor, and this is one we'll be looking at through this entire process today. But we have our SBOM. So our SBOM is just going to purely lay out everything that's in this particular image. So we'll see all the packages from our OS level packages. We'll see all the files within this particular image all laid out nicely here. All of our language specific packages. So if we have any NPM packages here, any Python packages, so on and so forth, all laid out nicely in a human readable format. We'll get any malware information. So every image that's added to Anchor will have a malware scan run against it. If it is present within this image, which in this case, we have a nice or not so nice crypto miner in this particular image, that will be flagged and then added to that SBOM. Additionally, we'll check for secrets within an image. So if there are any secrets or any keys or access keys or SSH keys, private keys, things like that left within an image by accident, we can service that information and it will be made a part of that SBOM. Then we can also look for retrieve files. If we want to see the contents of a certain file, we can have Anchor pull that in and see the file in its entirety here. And like Brian mentioned earlier, everything we're seeing here is 100% API driven. So we can interact with Anchor and see all of these same things through the API as well. For the SBOM, we can also retrieve it in a variety of formats. We have our in-house format, which is going to be our SIFT standard JSON native format. And we also have SPDX and CycloneDX if a different format is required. From there, we have vulnerabilities. That's going to be piece 2 to what we're looking for when we're going through a DevSecOps pipeline within a software factory. So we have our vulnerabilities. So we took our SBOM, we apply our vulnerability information on top of that, and then we're going to get a set of vulnerability results. And there's some nice things here that we can do as far as filtering goes. In the case of Iron Bank, they build on top of all of their own images. So they're really only interested in what they're adding on top of the base image because they maintain a set of base images themselves. So if I'm building my application on top of Iron Bank's Ubi offering, this filter right here for CVEs not inherited from base would be kind of nice because I can see what I'm responsible for adding on top of this base image that they've already done the remediation for the vulnerabilities and things inside of. So I can filter those out. We can also do some other checks, other filtering here. If we just want to see CVEs that have fixes and are not inherited from our base image, we can do that in any combination of these. We can also print these out as a report if we just need to, send this off to somebody for, just kind of an executive review, or someone needs to take a look at these vulnerabilities but not have access to the dashboard. We can do that here. That's available also as a JSON or a CSV output. And then we go one step further down, which is going to be our policy enforcement. And like Brian alluded to, this is going to be where we take some opinionated action on what is in our SBOM and the vulnerabilities present within this application as well. So we can use this to adhere to a variety of standards, like was mentioned earlier. So our NIST 853 standard, we have a policy pack for that. We have a policy pack for the Docker CIS benchmark. We have a policy pack to help with FedRAMP compliance. So all of these standards have slightly different controls, and we can use the policy engine to give us basically a final go, no-go action on an application or an image if there are things within that image that don't meet that particular standard. In the case of what we're looking at here, it's just a very simple policy that we're running against this that's looking for vulnerabilities that are going to be higher than a medium. It's going to throw a stop action, which means we'll stop and throw this final action of stop. It's going to look for malware, those secrets that we saw earlier, and then a couple other things. And the way that these policies are laid out is they're going to be sets of rules. So this policy we're going to be using here in just a second for in our pipeline. We have a couple of rules that we're looking at here. So we have a syskev rule, which is checking for vulnerabilities on the syskev list. We're doing some Dockerfile checks, which is going to be checking for root and some other thing, root user and some other things. We're checking if we have malware inside of that image, and then we're checking for secrets as well. So this is how Anchor works within, like, standing on its own, but how do we integrate this into a pipeline and go through this entire process? So we're going to kind of follow this workflow here. And this is running on GitLab pipelines. It's running a GitLab pipeline, and is just a very basic DevSecOps process that we can kind of mirror and take further as far as building out a software factory. But this is kind of a good base level of how this is done. So we'll go through each of these one at a time. So first, we're going to do an SBOM generation of our source code. So that's going to be of this particular repository here. And we can see we have a couple of things in here, but it's mostly just going to be our Docker file. We have some additional information like a README. We have this log4j jar file here, which is going to be flagged later on, and then a couple other things. So very basic repository here, but we're still going to generate that SBOM. So we'll generate that SBOM in the pipeline, and then we're going to return a policy result on that source code SBOM. And here we can see already within my repository, we're not off to a great start in this case. We can see we've got a few vulnerabilities popping, and they're against that log4j jar file that we have in this repository. But it's good as a full process and integrating with every stage of the SDLC, the software development lifecycle, that we want to get as much information at every stage as we possibly can. So in this case, we have our SBOM here. It's stored within Anchor, and we can do a policy check against that. Next, we're going to move on. We're just going to build the image. So we'll build this image. We're going to push it up to our registry of choice, and then it'll be made available so we can scan it with Anchor later. Very, very basic build. And a way that some of the software factories are doing this, and we'll take Iron Bank again, for example, is they're going to build the image and they tag it with a staging tag or a development tag. That development tag is used to track that image as it's going through the rest of this process. And only once it gets through final approvals and onto their main branch, does it get retagged to the final main tag, if you will, and push live to their registry. So there are a couple of ways of doing this promotion workflow. But in this case, we're just pushing straight up to our registry. The next stage, we're going to do two things. We're going to add the image to Anchor to have an SBOM generated for it. So when I do this Anchor CTL image add here on this image, it's going to be added to Anchor, and we'll generate an SBOM. And we're not going to take any action on it here yet, but we're going to allow Anchor to pull this image and generate the SBOM so we can use it later on. The other piece we're going to do here is we're going to run a static stig on this. So static stig is essentially running OSCAP under the hood, and it's going to take this image in, it's going to determine the base OS distro for this and select the appropriate compliance as code profile, and then run the stig against this image while it's static. The beauty of that is when we get these results, we're going to have a number of remediation steps that will show up in failed controls where we can build that remediation code back into our image so that when our image gets to runtime and we can no longer have persistent fixes for stigs, we know that we've at least taken action on that subset of findings that have failed and that they'll be passing in the future. This is an almost identical workflow to what Iron Bank is doing there, sticking these images, and then they build those remediation scripts back into their base images so that is propagated across all of their images made available to the public. So from here, and real quick, we can see all of our findings here showing up in the console. Also in job artifacts here, we'll just output these results in a variety of formats. So we'll have our OSCAP HTML file here, as well as a couple XML files, one for Stig Viewer that we can import into Stig Viewer and look at, and another for just our standard XCCDF results. The next stage is going to be kind of the bulk of our interaction with Anchor and our security checks. So once we've had that SBOM generated like we did here within our Anchor stage, we're going to do two other checks, which we looked at in the UI. We're going to do a vulnerability check first. And this is going to just pull back a list of all of the vulnerabilities that are present within this particular image. We can see we have quite a few here, but it's just going to be everything that's in this image. And it'll show us a couple things. We'll see our ID, our severity, the name of that particular finding, the version that the finding is showing up against. If there's a fix, we'll see that here, as well as some information from the vendor if they're not going to fix it, what type of package that's firing against, what feed it matched on. So within Anchor, we have our feeds that we're pulling from external sources. And those feeds are what we use to overlay the SBOM and generate these results. So we can see that this particular finding is coming from the GitHub Java feed group. Then we'll have the CVE ID, if appropriate, associated with this, and then an external link. So this link will go out to the GitHub Security Advisory page for this particular finding because it came from the GitHub feed group. So we have all of our vulnerability results here. We also will export these as a nice little JSON file so we can review these or import them into another tool if we're going to do our vulnerability assessments there. And then the other piece of this is going to be a policy check. And what this is going to do is run a policy check, just like we saw in the UI, and pull back the results so we can see them here in the UI. But we're not going to take action on this particular one. So in this case, we scan this image, we pulled it back, and we can see some evaluation information, including what image we're running against in the digest, And we'll see our final evaluation and final action. So we see it's a fail, and that's going to throw a stop action. And that just means we did not meet the standards that this policy is putting forth, and we need to go fix some things. So we can see it's showing a whole bunch of vulnerabilities that are of the criticality that we care about for this particular policy. We can also see we have some malware in here, so it's flagging that particular crypto miner that we have inside of here. And then a whole bunch of other policy findings. But then on the next stage, what we're going to do is we're going to do a pre-deployment critical vulnerability check. And this is going to be checking that policy that we looked at here for these particular sets of rules. So our SysACAV, our Docker file best practices, malware, and secrets. And when we do this, we're also going to add an additional piece to this, which is going to be the -F flag. And what this does is allows us to fail the pipeline based on the result of this policy. So whatever our final action is and our evaluation is, fail and stop is what is going to happen to this particular pipeline. So I built this image. It has these critical issues that we absolutely cannot have in our runtime environment. And we'll get to see them here. And it's going to stop my pipeline. So I know I need to go ahead and take some action on these. So we can see we have one vulnerability that showed up on the system known exploited vulnerability list and where it's located within this particular image. We'll also see that we have that malware showing up in this image. So that same crypto miner that we saw on the last slide or on the last screen. You'll also see that we have a couple of those secrets that we looked at before. So AWS access key was left in there, an SSH key was left in there, and then a couple of just private keys were also left in there. So we absolutely cannot have this in our runtime environment. So we need to go back and fix these. So let's just say for the sake of demonstration, I go back, I build a new image, and then we go ahead and run this pipeline. And this will go through the exact same process. I built my fixed image. We're going to do the same check again here on this exploited vulnerability check. And we'll see our results. We don't have anything firing here. And even though we threw the -F flag, our final action is a go, so we'll allow this pipeline to continue on. And then the next stage of this can be really anything that we want. In most cases, this will be promoting to a production registry. In my case, I'm just going to deploy it within my cluster. So I'm just going to use Argo here, and I'm going to deploy this particular image in this cluster and then sync it. So we've kind of gone from our code all the way to fully deployed within our cloud and ensuring that we're doing our security checks, that we absolutely need to make sure we're not having any of these findings in our final runtime environment. And then kind of fully rounding this out, another and final piece of Anchor that's extremely useful when it comes to monitoring this long-term beyond just building the initial software is going to be our Kubernetes integration. And what this is a lightweight runner that runs within our cluster, and it's going to report back all the images in that cluster to Anchor, and we can see both our security posture of those images and if there are any images in there that we don't know where they came from, or how they were deployed, or any images that are deployed in our cluster that somehow circumvented an Anchor scan. So we're tracking one cluster here, and we can see we have 57 images in this particular cluster. And I can see the state of each individual namespace and the images within there of if they've been evaluated first off, and if they're compliant with the default policy bundle that we're running. So let's take this STIG testing namespace here, for example. We have 4 images in there. We're 100% evaluated. So all of those images have been evaluated by Anchor, but only 50% of them are compliant. And we can dig in even further and see which particular ones are compliant based on our default policy bundle that we're running. We can see the image that's actually running here, the digest of that image, when it was last seen within the cluster. So if we deployed it and it's running, this will constantly be reported back as it's still running in there. And also we can set a TTL on this to see, have these kind of cleaned out as images are coming and going within our cluster. And then we can also see if particular namespaces haven't been evaluated. So I have a watch on certain namespaces in here, but we can see others, like this Artifactory one, has 6 images in it, but none of them have been evaluated, so we don't have any policy compliance. And at this point, we can say, okay, I absolutely want to see what is going on with these images. I can click this watch namespace, and it will go ahead and fire off, retrieve those images, and then Anchor will start scanning these so we can get all of that information here within the dashboard. So that kind of rounds out this entire workflow. So kind of just recapping a little bit for the pipelines, we kind of want to have a touch point at every part of this process. So that's going to be from our source code. We're generating our SBOMs, doing some policy checks there. We're going to build that image. We're going to add it to Anchor to be scanned and have an SBOM generated for it that we can then use long into the future. We're doing our static STIGs check here so we can build some of those findings back into our image. We're going to do an initial policy check, and this can also be just a single policy check that we're failing if there are issues within that pipeline. But in this case, we did 2 checks in this particular example. And we're going to do our vulnerability check. So we're kind of seeing everything from the SBOM to our vulnerability information to our policy information as we go through this process. And then we can make decisions on those and how we want to promote images or deploy images beyond there. All right, and I am going to stop sharing here.
Michael, that was fantastic. Thank you.
Of course.
And we have a lively crowd in the chat box today. Thank you, everyone, for weighing in on the feedback for the audio and then also on the compliance regulations poll. We do have a few questions that have come in, and there's one that Felicity just dropped in the question box. Can you see that there, or would you like me to read it?
I can see that, yes.
Okay.
I'll go ahead and read the question for everyone. So Felicity asks, are you familiar with the NAVC eMaster RMF automation tool? We are required to use this to review container SBOM files to incorporate their findings into our POAMs. The SBOM files have to be in Excel or CSV format for the eMaster tool to ingest. Can this application generate SBOM files in these formats? So yes, we can generate them in those formats. It's just an external process that we're going to have to do that with. So when we retrieve the SBOM from Anchor, it's going to be in a JSON format. And then, like Brian mentioned earlier, our SIFT tool is the kind of SBOM engine that underlies all of this. And that has the ability to, the name is escaping me, use templates. So they're standard Golang templates, and there's one available for CSVs directly from SIFT. So you can quickly convert from your JSON format to your CSV format and then upload into that, that eMaster RMF automation tool.
All right, great. We got a couple via email as well. Is the DoD software factory model essentially how the military and government approach building software? Are these approaches that the DoD created independently, or are they borrowed from the corporate structure?
So yes, this is kind of the standard format across the board for the DoD. At least it's going that way. In the past couple of years, we've seen huge advances where I'd even say that the DoD is going faster than the industry as far as implementing these DevSecOps procedures, which is awesome to see. We can't say that about everything within the DoD and the speed that things progress, but the DoD really is kind of leading the charge in implementing these DevSecOps procedures and these processes to, kind of find that balance between security and ease of development for those developers.
All right, great. Looks like Brian dropped a question in about static STIGs. For the static STIG check, how do you handle base images? I'm gonna let you go ahead and take that through there.
Yep, absolutely. So the question is, for static STIG checks, how do we handle base images like UBI9 minimal, where the STIG checker will flag a bunch of findings for rel 9? That's a great question. So we're at the moment running compliance as code profiles. Since there's not one for UBI9 minimal, you will have to run the full rel 9 set of checks for that. And then at that point, we'll just have to go through and see which ones aren't actually applicable to UBI9 minimal, unfortunately.
Perfect. Brian, hope that answered your question. And then we have another one from Hans about Iron Bank.
All right, so Hans said, you mentioned Iron Bank does a very similar remediation process. Is this done for the images provided from industry as well, or does that need to be handled and remediated by the individual companies? That's a great question. So Iron Bank provides the infrastructure for external industry members or vendors to bring their software in. So we as Anchor do this with our own software. So every release will bring our software in. It's going through a process very similar to what we looked at today. and then we'll be the ones submitting our justifications for any findings that are still present in our images. And then from there, Iron Bank will review all of those findings with their internal security team, and then they'll process it and push it through the rest of the build process so that our versions are made available. And currently there's quite a few open source images in there, but there's easily 10 times as many vendors going through this process right now as well.
Okay, awesome. We had one in from Sherry. She says, what's the best place to start with building a software factory internally?
I think it's going to be laying out what the process will look like before you even start pushing code through that pipeline. So it's going to be kind of looking at the process that we went through today and which stages we want to integrate with our security tools and how we're going to basically take our code from the code just purely written and not fully built to a fully containerized application that we're ready to deploy, or even going further and deploying that. Once we have that all laid out, we can push through some test things to see and ensure that our processes are working correctly and that we're getting results that we want. And then specifically with those results, how we want to go about reviewing those findings. So for example, Iron Bank went through a process of switching from Excel documents when they initially were reviewing findings. So it was vendors would submit an Excel spreadsheet that had all their findings and the justifications. Once they get to scale, they realize that's not really going to work all that well. So they came up with their vulnerability assessment tracker, where vendors can go submit their vulnerabilities directly to Iron Bank, and they can be reviewed, as well as some other information about timing on those vulnerabilities as well. So once we get all these processes in place, then we can go and then start building our software and pushing it through this pipeline.
All right, great. Sherry, I hope that answered your question. All right, that wraps it up. That's all the questions that we had. Is there anything else that you wanted to address? Are we good?
I don't think everything else to. Let's see, one more in from Kevin. So Kevin says, do you provide capabilities to capture responses to findings shared between deployment teams and ISSOs? So yes, we do. So Anchor itself, we have the concept of accounts, and what accounts are is basically data isolation. So we see people use this for different teams or different projects, and they will basically have those particular users on that account, and they can see all of their images, and then we can grant cross-account access to particular users. So say I'm a developer working on multiple projects and I need to see different sets of images within Anchor, I can be granted cross-account access. We can also inherit all of this from LDAP systems or SSO systems like Keycloak or Active Directory.
All right, perfect. Let's see. So here's our next steps. Folks can go ahead and get a demo of Anchor. You can download some assets we have, and we'll also share a white paper that we have available on SBOMs for you. But thank you everyone for joining today, and thank you, Michael. This was great. Thank you to you and Brian.
Of course, thank you all.
All right, take care, folks.